Ever wondered how a massive steel tube weighing thousands of tons can silently patrol the darkest depths of the ocean, becoming the ultimate predator? Submarines are one of the most incredible feats of engineering, blending physics, acoustics, and pure ingenuity to dominate the underwater battlefield. Today, we're diving deep into the science of submarine warfare. First, let's talk about how these giants even get underwater. It all comes down to buoyancy, a principle discovered by Archimedes over 2,000 years ago. A submarine has large tanks called ballast tanks. To dive, huge valves open, letting seawater flood into these tanks. As the sub takes on more water, its overall density becomes greater than the surrounding water, and it begins to sink. It's like a controlled fall into the abyss. But how does it stop at a specific depth? This is where the magic of neutral buoyancy comes in. By carefully managing the amount of water in the ballast tanks and using smaller trim tanks for fine-tuning, the submarine can achieve a state where its density perfectly matches the water around it. At this point, it neither sinks nor rises. It just hangs there, suspended in the water column. To surface, powerful pumps force the water out of the ballast tanks, replacing it with compressed air. The sub becomes lighter than the water again, and it gracefully rises to the surface. It's a delicate dance with the laws of physics. Now, staying hidden is the submarine's greatest weapon. Its primary enemy is sound. Underwater, sound travels much faster and further than it does in the air. A single loud noise can give away a sub's position from miles away. So, modern submarines are obsessed with stealth. Everything on board, from the nuclear reactor to the air conditioning, is designed to be as quiet as possible. The main source of noise used to be the machinery, especially the propulsion system. Nuclear submarines use a reactor to create intense heat, which generates steam to turn turbines. These turbines can power the electrical generators or directly turn the propeller shaft. To minimize noise, this entire system is mounted on massive, complex rubber mounts that act as shock absorbers. These mounts isolate the machinery's vibrations from the hull, preventing them from radiating out into the water. It's like putting the entire engine room on a giant set of noise-canceling headphones. Even the shape of the submarine is crucial for stealth. Early submarines had blocky, angular shapes, but modern ones are teardrop-shaped. This hydrodynamic design, inspired by the shape of whales, allows them to glide through the water with minimal resistance and turbulence. Less turbulence means less noise. The outer hull is also covered in special anechoic tiles. These rubbery tiles are designed to do two things: absorb the sound waves from enemy sonar, preventing them from bouncing back, and dampen the noises coming from inside the sub itself. It's like wrapping the submarine in a cloak of invisibility for sound. So, how does a silent hunter find its prey? The answer is sonar, which stands for sound navigation and ranging. There are two main types, active and passive. Active sonar is what you see in the movies, the classic ping. The submarine sends out a powerful pulse of sound and listens for the echo that bounces back off an object, like another ship or a submarine. By measuring the time it takes for the echo to return, the sonar operator can calculate the distance to the target. It's very accurate, but it has a huge drawback. That ping is like shouting in a quiet library. It instantly reveals your own position to anyone who's listening. That's why submarines prefer to use passive sonar. Instead of making their own noise, they just listen. They are covered in an array of highly sensitive underwater microphones called hydrophones. These can pick up the faintest sounds from incredible distances: the thrum of a propeller, the hum of a ship's engine, or even the sound of another submarine's crew talking if they're not careful. These hydrophone arrays are incredibly sophisticated. Some are mounted on the hull, while others are towed behind the submarine on a long cable, sometimes miles long. This towed array sonar gets away from the noise of the sub itself, allowing it to hear even quieter targets. The computers on board analyze these sounds, comparing them to a vast library of known sound signatures. A skilled sonar operator can tell the difference between a cargo ship, a destroyer, and even a specific class of enemy submarine just by the unique sound it makes. They can determine the target's speed, depth, and direction, all without making a single sound themselves. It's a deadly game of cat and mouse played in total darkness. Once a target is found, it's time to talk about weapons. The primary weapon of a modern submarine is the torpedo. These are essentially small, self-propelled underwater missiles. When a torpedo is launched, it doesn't just swim in a straight line. Modern torpedoes are incredibly smart. They can be guided by a thin wire that unspools from the submarine, allowing the sonar operator to steer it in real time. Once it gets close to the target, the wire is cut and the torpedo's own onboard sonar takes over. It has both active and passive sonar to hunt its prey. Even if the target tries to evade, the torpedo's computer can predict its movements and adjust its course to intercept. But torpedoes aren't the only threat. Many submarines, especially ballistic missile submarines or SSBNs, carry a much more powerful payload. These are the ultimate deterrent. An SSBN can carry multiple intercontinental ballistic missiles, each armed with multiple nuclear warheads. A single one of these submarines carries more destructive power than all the bombs dropped in World War II combined. They patrol the oceans silently, their locations unknown, providing a nation with a guaranteed second strike capability. Their mission is not to fight, but to prevent a fight from ever happening. Life aboard a submarine is a unique challenge. The crew lives and works in a confined space for months at a time, with no sunlight and limited contact with the outside world. The air they breathe is manufactured. Oxygen is generated by splitting water molecules through electrolysis, and carbon dioxide is removed by chemical scrubbers. Fresh water is made by desalinating seawater. It's a self-contained world. The psychological pressure is immense. The crew must be constantly vigilant, listening for any sign of a threat. Every creak and groan of the hull under the immense pressure of the deep ocean is a constant reminder of their hostile environment. A tiny mistake could be catastrophic. That's why the training for submariners is among the most rigorous in any military. It requires a unique combination of technical expertise, mental fortitude, and teamwork. From the simple laws of buoyancy to the complex art of acoustic stealth, submarine warfare is a testament to human ingenuity. It's a silent world where physics is the weapon, and the slightest sound can mean the difference between hunter and hunted. These incredible machines continue to patrol the deep, unseen and unheard, the silent guardians and predators of the ocean. Thanks for diving into the science with us today. If you found this fascinating, make sure to hit that like button and subscribe for more deep dives into the world of science and technology. Let us know in the comments what other incredible machines you want us to explore next. See you in the next one.